Welcome back to part 2. We're going to pick up right here where we left off with cosecant. Now, if you remember from the unit circle, we discovered that it was 1, cosecant is 1 at pi over 2. So at pi over 2, it's at 1. At 3 pi over 2, it was negative 1. All right, and likewise here at negative pi over 2, negative 3 pi over 2, and it was 1.4 at pi over 4. So at pi over 4, it was just a little bit less than half. Okay? Be negative. Look what's happening. It's flipping up. Okay? It's flipping down. So that point right there at pi over 2, 1, and at 3 pi over 2, negative 1, those become minimums and maximums within that period. So you can take this, and sometimes it's helpful to draw the sine graph because then you can figure out where those minimums and those maximums are. All right, where you, this doesn't have, because this is the real graph. This is the secant graph, cosecant graph, excuse me. That is not here. This was just the sine graph. So this doesn't have an amplitude. Look, this is going to keep on going forever and ever and ever. It has a minimum for this branch, and it has a maximum here. So again, let's talk about our asymptotes. Our asymptotes now are multiples of pi. It's still vertical, is a multiple of pi, and our range is now from either 1 to infinity or negative infinity up to negative 1, but it does not exist here between, the range doesn't anyway, between the negative 1 and the 1. So let's mark our range is negative infinity to negative 1, and it includes the negative 1, or 1 to infinity. The domain is now anywhere, obviously, except all of the x's, anywhere except those asymptotes. So we still have x is all real numbers, except it cannot equal a multiple of pi. Your x-intercepts, your y-intercepts, it will never intersect this x-axis here, and it will never intersect the y-axis. So we don't have any x-intercepts or y-intercepts. Is it continuous? All right, it has an infinite discontinuity at those asymptotes. Discontinuous at the asymptotes. And the symmetry, this one is symmetrical to the origin. All right, I can still spin that. All right, I can spin these, and it was still symmetrical to the origin. So it is still odd. End behavior doesn't exist, because it keeps on going and it oscillates again. So we still do not have any end behavior, and it still oscillates between the negative infinity and infinity. Now let's talk about secant. Secant is 1 over cosine. So similarly, if we go back to our unit circle, and you look at 1 over, let's see, secant is 1 over cosine. Well, where is cosine 0? That would make that undefined. Well, cosine is 0 here at the pi over 2's. So here, the secant is undefined. But at the pi values, you have 1 and negative 1. So the secant would be 1 over 1. So that would make my secant value 1. And here it would be 1 over negative 1. So my secant is negative 1. And when I do the pi over 4 values, they're the same thing. So this is still the square root of 2 over 2. So here my secant value is about 1.4. Over here at 3 pi over 4, here I have a negative square root of 2 over 2. So my secant of 1 over cosine is a negative 1.4. Okay, down here, my cosine value in 5 pi over 4 in quadrant 3, these are negative. So my secant value is also negative. Here in quadrant 3, this is positive square root of 3 over 2. So my secant value is positive 1.4. Now how does that correspond back to the graph? Again, let's remember our asymptotes are now at the pi over 2 points. So we're going to come back here and we're going to say asymptote at pi over 2's. If you remember, this is similar to the tangents. And we're going to say that we have zeros. Remember, we have, it doesn't ever equal 0. Secant doesn't. But it's 1 at the pi values. Well, that's unusual. Let's try to sketch out the cosine graph. The cosine graph, remember, is high here. Let's do it this high, then it goes low, then it goes back up high again. Just doing that very lightly so that you can see secant at the 0 and 2 pi is 1. That means it's right here at 0 or at 2 pi, it's at 1. And then at pi over 4, remember, it was up at 1.4 again. It's doing this number again. It's flipping up. And here it was negative 1. It's a minimum. There's another minimum. This is a maximum. This is a maximum. And this would be half of a minimum as well. Well, now let's analyze that. You see that your asymptotes now are at the pi over 2's. All right, so our asymptotes are still vertical, and they are at pi over 2 plus a multiple of pi. And therefore our range again is only from 1 to infinity and negative infinity up to negative 1. Our range, negative infinity to negative 1, and includes that, and then from 1 to infinity. Our domain, again, exists everywhere except at those asymptotes. So x is all reals except it does not equal where my asymptotes are at multiples of pi over 2. Intercepts, here I do have a y-intercept. You see that? I have a y-intercept at 0, 1. Well, that changes a little bit because I still don't have an x-intercept, but that changes my symmetry. If I have a y-intercept there, do you see how that is now symmetrical to the y-axis? Well, that's different. This is y-axis symmetry. That makes this one even. That hasn't happened in a while. All right. We still don't have an end behavior because we still keep oscillating. So that still doesn't exist, and this still oscillates between negative infinity and infinity. I left off continuity. It is still infinitely discontinuous. Discontinuous, I apologize for abbreviating everywhere, at asymptotes. The equations. Let's look at the equations if you want to look at those. I'm not going to spend a whole lot of time on these because you've seen this before, and I really hope by now you're discovering and remembering what all the different pieces are. All I did was put in secant or cosecant, But now, look at the period. The period is now, normally tangent and cotangent, we just did asymptote to asymptote. But here, you need to have a full period that's 2 pi. You need to have, like, from negative pi to positive pi. So you need to have this whole period of 2 pi. You need to have basically a minimum and a maximum turn within a period. And therefore, when you go back to giving me the period, you're still going to use the 2 pi over b. So this is the same as sine and cosine. So you need to remember that the tangent and the cotangent is different, but this one's the same. Now we talk about extreme asymptotes, and that's because you're not just giving me the asymptotes in between each branch, you're giving me the whole period. So I'm going to write down here, this is of 1 period. So you need to remember, basically you have a maximum and you have a minimum value. You need to remember that this, I want both of them. I want the max and the min. All right, I'd like to do some examples. Let me pause while I set that up real quick. I'd like to do these examples now, and if you want to just pause it for a minute and get this set up, that would be good, so that you can have this, because I may not finish all 4 by the end of this video. Example 1, we are going to do a tangent graph, and I would like to graph y equals tangent 4x. So first we need to determine the period. Remember, the period for tangent and cotangent, for that matter, is pi over b. Well, here b is 4, so that makes my period pi over 4. Well, I'm going to write a little note down here. The parent graph had a period of pi, and it went from negative pi over 2 to pi over 2. That was our parent graph. I'm now going, so instead of going from here to here that went from pi as a period, I now have a period of pi over 4, which means I'm going to not just come in by pi, I have to come in even smaller, and I have to come in pi over 8. So my asymptotes are going to go right through the middle here. That is 1 period right there. Here's another period that's going to cut this one in half. Right? So my asymptotes are x equals pi over 8 and x equals negative pi over 8. Now let's graph that. That's of 1 period. When you graph that, remember the tangent started, crossed at 0, 0, and then it went up to 1, went up 1 right there, and down 1. This is a little hard to graph because it is so tiny and compacted. It's going to be right in there. This one would cross there at pi over 4 would be a 0, and it would cross right there and go up and turn and go down. Okay, you could graph another one if you wanted to. You really need to graph at least 2 periods per graph. And some of you are going to get really creative and do all sorts of colors and things when you do these. That would be awesome to show us. Some people are going to want to make colors on the graph. Some people are going to want to make colors on the asymptotes. As long as you're consistent and label it, I don't care. All right, let's graph the cotangent one. Cotangent, if we have a period, we still are using pi over b, and here our b is 1/2, right? Because that's like 1/2 times x. So here, if I have pi over 1/2, that's really 2 pi. All right, I'm going to write down here just so that I remember my parent graph was a period of pi for the cotangent. It went from 0 to pi. Well, I'm now shifting it. Instead of it being only a distance of pi, it's now going to be twice that. So instead of going from 0 to pi, here for just one period, I'm now going to be going twice that, from 0 to 2 pi. All right, that symbol, that alarm, tells me that I need to stop this particular graph and that we need to pick up when we come back in class. So we will finish this. I will stop right here, and we will finish this graph in class, and then we will do the cosecant and the secant graphs. I would like you to at least have that set up, and you can tape the graph paper down, and we will finish that when you come finish lesson 4-5 and do these examples, because it's real important that we do each one of these before we do the graphs. Remember, no calculator when you're graphing these. I'll see you then.